This is part 8 of the series, The Basics of Geometry, and in this part we're going to continue our discussion of angles with the idea of measuring angles. And so to measure an angle we would use units called degrees. Now alternatively we're also going to use units called radians. That has a completely different meaning from a degree. We're going to look at that a little bit later. But radians and degrees are units of measure to measure degrees. For the most part, from this point forward until we get to the discussion of radians, we're always going to be using degree measures to measure our angles. A circle contains 360 degrees, and it's denoted like this with the little degree symbol sitting here. Now, all of the angles we're going to be dealing with in this course are going to be less than 360 degrees or equal to 360 degrees. In other courses, you will be dealing with angles that are greater than 360 potentially. But for this case, we're just going to consider anything up to and including 360 degrees from 0 degrees. So let's continue on and look at how we would actually measure an angle. To measure angles, we generally use a device called a protractor. Now, this protractor has graduated scales on the outside and on the inside of the protractor. And these scales go from 0 to 180 on both sides and in both directions. Now, there's a multitude of types of protractors out there. If you're going to buy a protractor, what you want to look for is a protractor, first of all, that's clear, because you're going to be laying this over the top of a piece of paper. You want a protractor that has an index. This index, we're going to talk about this in a second, but it's an object that you position directly over the top of the vertex of an angle. Now, some protractors out there have a very large circle where the index is supposed to be, and that makes precision extremely difficult. So a simple protractor is usually the best protractor. Some protractors have these little slides that allow you to draw angles and things like that. These are just more devices that can break off. I like the very basic, very simple protractor that has a graduated scale on the outside and the inside, and it's usually best, this one is a digital protractor of course, but most of the protractors you would buy would have a scale, a linear scale, such as like a ruler on this bottom edge. But in either case, you want an index that is on line or collinear with an index line, because this index line is going to be lined up with or on top of one of the rays of your angle. So it's really important that this and this are at the same level. It may be surprising for you to learn that some protractors aren't like that. You have to learn how to use them a little bit more effectively. It's sometimes not intuitive. So again, I would pick the simplest, most basic type of protractor. So having introduced protractors, let's go ahead and try to use this to see how we measure an angle. In this image, I've drawn several rays that have a common endpoint here, and I want to find the measure of these different angles. So you can see we have one on the right, one in the middle, and one on the left. Well, in order to do this, I'm going to pull up my protractor. So here's my protractor. Now what I'm going to need to do is I'm going to need to take this protractor and line up that dot, the index, with my vertex of my angles. And as I do that, I'm going to line up this index line with this side of the angle. So I'm first going to measure this angle. So I'm going to take this, line it up here, and this, and line it up there. So the first thing, I need to select my protractor. Now I'm going to go ahead and I'm going to line up my protractor so that my index is directly over the top of my vertex, and my index line is lined up with this side of the angle. And you don't need to make it super precise. It just depends on how accurate you want to be with your results. So that looks close enough. Now, the way we read this is this angle is clearly a small angle. So we're not going to be using this outer scale. So smaller angles, we're going to use this inner scale when we measure from left or from right to left. So on the right hand side, we're using this inner scale. And this is going from 0, and we read off of this line. So it looks like we're at 35, 36. It looks like it's going to be about 37 degrees. So we would say this angle is 37 degrees. So let's go ahead and write 37 degrees in here. Okay. Now for this angle, we're going to use the outside. Notice how the outside starts at 0 here and gets greater as we move up this way. So this angle is clearly a relatively small angle, so we're going to use the outside scale for this angle. So we're going up here, and it looks like it's about 51.5. We're going to say 52 degrees because we don't have to be super duper precise here. So let's say 52 degrees. Now, for this central angle, there are several ways we could do this. If we wished, we could go ahead and rotate this protractor around so that without moving the index, we would rotate the index line so that the index line is lined up along this line. Alternatively, what we can do is use what's known as the protractor postulate. And just like we had the ruler postulate said that the measure of the distance between two numbers on a number line is the absolute value of their difference. Well, we can do the same thing with the protractor postulate. The protractor postulate says that if we have two rays, they can correspond to numbers, real numbers, on a protractor scale. The distance between those two rays is given by the absolute value of the difference of those numbers. So to find this angle, we would use, let's go ahead and use this inner scale. So what we'd have here is, we said that this was at 37, so it'd be 37, and this one was 52, but in actuality, we're going the inner scale, so that's going to be 120, looks like it's going to be 128. So minus 128, and it's the absolute value of those two values, which is going to be the absolute value of 91, which of course is 91. Now just for kicks and giggles, we could go ahead and verify this by going ahead and rotating this protractor. So let's go ahead and try that, see what happens. So here we selected our protractor. Let's go ahead and rotate it up. And we're probably going to have to do this a couple of times. Let's line this up. And we'll have to rotate it a little more. Looks close. Move that over. And let's see, there's our line. And then if we look, read it off the top scale, we can see that it's about 91 degrees. So that's pretty close for government work. So there you go. That's how to measure angles using a protractor. In case you're keeping notes on this, let's go ahead and formalize the protractor postulate that we just got finished looking at, and then we'll move on. So here we have a more formal description of the protractor postulate. Given line AB with point P between A and B, so point P between A and B, rays of the form PC, so we have a ray here, PC, PB, and PA, can be paired with real numbers from 0 to 180. So we compare these with numbers on the scale from 0 to 180. The measure of angle CPB is written, the measure M, in front of the angle symbol with the name of the angle. The measure of angle CPB is given by the absolute value of the difference of the real numbers associated with the rays PC and PB. So here we have PC, which is associated with the value of 50, and ray PB associated with the value of 0. 50 minus 0 is 50. So that's the protractor postulate. All right, now we're going to look at classification of angles by their measure. Most of these classifications you should have seen already. If not, this will be a little refresher for you. An acute angle is an angle whose measure is greater than 0 and less than 90. The next classification is a right angle. A right angle is an angle whose measure is equal to 90, and you will characteristically see this little square that's in this interior of the angle. It's not necessary for that to be there, but if it is, you know that this is a right angle. If it's not there, it still may be a right angle, but you can't assume that it is a right angle. Even though it may look like a right angle, you're going to have to rely on the information given rather than on the picture. That's rule number 1 in geometry. Never trust the picture. Always trust the information that's given to you inside the picture. All right, the next classification are obtuse angles. An obtuse angle is an angle whose measure is greater than 90 but less than 180. And notice that it falls past the vertical here. The next classification is a straight angle. A straight angle is an angle whose measure is equal to 180. Notice this is half of a circle. Half of a circle, since a circle has 360 degrees, half a circle has 180 degrees in it. So this angle is basically half a circle here. And the last classification, this is not going to be in the book, but it is called a reflex angle. And a reflex angle is an angle whose measure is greater than 180 but less than 360. Notice how the angle, the terminal side of the angle, passes the horizontal. It goes past the horizontal. Notice that the other side is going to be an obtuse angle, necessarily. It could also be an acute angle. It could be a right angle over here. But this reflex angle is always going to be greater than 180 and less than 360. The next set of topics we're going to look at are all linked together, so I don't want to rush them through and fit them on this video. So we're going to go ahead and terminate the video now, and we're going to look at the next set of topics related to angles in the next video. So I will talk to you in the next session.